Okay, a question on centre of mass from June 2010, question number 3, on the Edx M2 paper. So here's the question. You might like to pause the video and just take a moment to read it and carry on when you're ready. Okay, we've got a triangular frame made up of 3 pieces of rigid rod of lengths 10, 10 and 12. We've got to find the distance of the centre of mass of the frame from BC. So we know by symmetry that the centre of mass will be on that line, that symmetry line. We've got to find where it is on that line. So let's make a table up, as we usually do in questions like this. So you might like to just pause the video and make this table up. Masses in the top row and distances from BC in the bottom. Okay, continuing then. The masses are taking the lengths as the masses. The masses are 10. Just so I probably get my pen to work there. 10, 10 and 12, and the total mass is 32. The total, the distance of the centre of mass of the whole thing is what we're trying to find. Now distances from BC, well the easy one is for rod BC, the distance is 0. And for rods AB and AC, the centres of mass of the rods are there, halfway up the rods. So the distance from the bottom is halfway up this line, A to, let's call that point M. Now here's a triangle showing you an enlarged view of AMB. So the side AM is of length 8. So this bit here is of height 4. That's 4 and that's 4, because that's halfway up that side. So the for AB and AC, the heights are both 4. Nearly there. All we've got to do now is take moments about BC. 32 times x bar for the whole thing times its distance is 10 times 4 plus 10 times 4 plus 12 times 0. And that gives us 32x bar equals 80. So x bar is 2.5. And that's part A of the question done. 5 marks. There's 4 marks remaining for part B, which I've got on the next page. Right, so the top diagram shows the original frame, and we know that the centre of mass of the whole thing is here then. Here at a height of 2.5, x bar was that distance. And in this second part of the problem, they say the frame is total mass capital M, and another particle of mass M is attached at the midpoint of BC, so attached there, and then it's hung freely suspended from B and hangs in equilibrium. This is one of those questions where we've got to find the angle, in this case the angle between BC and the vertical. So you have to take a moment to think about what it might look like hanging like that, and I've had an attempt at it. So if this is B here, and C, this is a mass M, so the weight of it is capital mg there. This is the whole the centre mass of the frame, that's an mg there. This is the point of suspension, then B. And we want to find the angle between BC and the vertical. Well, the centre of mass of these two particles of mass capital M is halfway between them. And so it'll be there, say. Let's do that in a different colour, let's do it in red. And that will have to be vertically below the point of suspension. So that's the red mass is the centre mass of the whole thing now, which we know is halfway between the two capital M's. So all we've got to do here to find the angle, and it's this angle that we want, just put it in, this angle here. The vertical is the line, let's call this G. The vertical is the line from B down to G. We've agreed that G is halfway along this line. So if we call that point M again, mg is a half of x bar, a half of the distance we found in the first part, which is a half of 2.5 or 1.25. Now, this distance here is 6, so we can now find tan theta. Tan theta equals mg over mg, that should say, over 6, which is 1.25 over 6. And that gives us, if we check on the calculators, that gives us theta equals 11.8 degrees. And that's 4 marks earned. So as far as the allocation of marks for this, for the first part of the question, there was a total of 5 marks, 2 marks for the terms in a table of this sort, in other words the correct masses and the correct distances, then a method and 2 accuracy marks for taking moments about BC and finding the x bar. That's the 5 marks for the first part. The 4 marks for the second part, well, there was a mark for finding the distance mg, either by taking moments about the vertical through B, or by just looking at it and figuring out that it was half x bar. So there was a B1 for that. And then there was an M1 and 2 accuracy marks, M1A2, I guess for drawing the diagram really and figuring out how to find tan theta from the relevant triangle there, the mg over 6. Yep, that was the 4 marks for the second part then. 1 method and basically three other marks for writing down the correct values. Okay, that's question 3 done. Hope it was of some use to you. I'll leave you with some information about the Further Maths Support Programme.